Hello everyone, this is Mrs. Johnston. We continue our study of patterns with analyzing number patterns today. And I have a chart here, 1 through 40, and we're going to see if we can figure out the pattern here. Well, first of all, I'm going to highlight our multiples of 2, and I'm going to go ahead and highlight all of these multiples of 2. Basically, we're just skip counting 2, 4, 6, 8, 10, 12, 14, 16. Do you see there's a pattern? 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. We do see a pattern. All of the 2's are in the same row when they're lined up by 10's. 10, 20, 30, 40. Okay, let's get another color. Let's see, colors. Here we go. Now we're going to do the multiples of 4. Let's see what we notice. Let's see, this worked before, this worked before. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Huh. What do you notice? 4. Look what kind of pattern that makes. Did you know that every 4th number there is a color shaded in? But do you notice that on the 2's, when we skip counted for the 2's, there's also a 4 shaded in? What do you notice about that? Think about it. What if we had put in for the 8's? Let's put in for 8. 8, 16, 24, 32, 40. All of these numbers that we did for 8 have a 2 and a 4 in them. Those kind of look like candy canes to me. What do you think? All of the numbers showing 2 or 3 shades are multiples of 2 and 4. This has multiples of 2 and 4. This has multiples of 2 and 4. This has multiples of 2 and 4. 2, 4, 8, 2, 4, 8, 4, 8, all 3. I wonder what that means. Those are all patterns. How cool. That's something to think about when you're doing your multiples of 8 or multiples of 2 or multiples of anything. I wonder if we were to go even further. They're all even numbers too. Pretty cool. Okay. Okay, so just like we were just talking about, these are the multiples of 2 and 4. 2, 4, 6, 8, all the way up to 32. 4, 8, 12, 16, all the way up to 64. Why do multiples of 2 appear in the list of multiples of 4? Look at that. Let's see, with 4, 8, 12, 16, 20, 24, 28, 32, let's see. Why is only every second multiple of 2 also a multiple of 4? So every second one. Yeah, that's interesting. Every second multiple of 2. So this is a second one. So there's 4, and then 1, 2, 8. Interesting. 1, 2, 12. 1, 2, 16. 1, 2, 20. 1, 2, 24. That's interesting. 1, 2, 28. 32. There is no, oh wait, 28 and then 32. Is 32 on here? Yep, right here. That's very interesting. That's another pattern that we can be interested in trying to figure out. These are just different patterns I'm trying to show you about numbers. I have a whole list of them. That would be interesting to find out. Okay, what is this slide showing us? We're going to think about multiples, the relationship between multiples of 2 and 8. Why do multiples of 2 appear in the list of multiples of 8? Let's see. 8 and 8. 16 and 16. 24 and 24. 32 and 32. Why do those multiples appear in the same list? Why do you think? And why is only every fourth multiple of 2 also a multiple of 8? Well, let's count that. 1, 2, 3, 4. 8 and 8. 1, 2, 3, 4. 16, 16. 1, 2, 3, 4. 24 and 24. 1, 2, 3, 4. 32 and 32. And that just so happens to be those are the first 4. I bet if we kept going, we'd come up with 40. Those are things for you to discuss, maybe with somebody in your family, or perhaps when we come back to school, talk with students in the class. Okay. Discuss your ideas with someone. That would be something interesting to talk to somebody, perhaps at dinner time. Talk with your family. Oh, here we have the same table, but now multiples of 4 are on it. Why do multiples of 4 appear in the list of with multiple 8? Let's take a look. What do you notice? There's a 4, 4. Look, 8 8 and 8. What links all the different multiples together? What are all of these multiples? Why are they linked? How can they be linked together, do you think? 2, 4, and 8. All of these multiples, how are they linked together? I can think of one. All of these multiples can be divided into twos, I think. I can do 2, 4, 6, 8. The number 2 can go into 4, and the number 2 can go into the number 8. 2, 4, 6, 8. So for instance, I can do 2 plus 2 equals 4 plus 2 more plus another 2 equals 8. There's lots of ways we can get to 8. I'm sure we could have a discussion on that. That's one way. And also, there's different equations we can use. Aha. So if we have the number 40, 5 times 8 is 40. And if we break that down into 5 times, we break down the number 8 into 2 times 4, says 8 is the same thing as 2 times 4, right? Because 5 times 8 is 40. We're breaking down 40 in 5 times 2 times 4. Or you could say 5 times 2 and then times 4, because 5 times 2 is 10. And then times 4 equals 40. And the same thing was, they have 56 can be broken into 7 times 8. And then the 8 can be broken down into 2 times 4. So they brought this down. So 7 times 8, which is broken down into 2 times 4. Or you can break it down, they're putting the 7 times 2 is 14 times 4. And 14 times 4 is 56. 14 times 4. So 4 times 4, carry the 1, 16. 4 times 1 is 4, plus 1 is 5. So we have another one. Multiples of 3, multiples of 6, it's the same thing. There's patterns in here, 3 and 6. So if we did 3, 6, 9, yep, it's the same thing. 3, 6, 9. There's patterns for multiples of 3, 6, 9. It's like skip counting. 3, 6, 9, 9, 18, 27. 3 times 3 is 1. 3 times 2 is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's skip counting. Yep, 3, 6, 9. 30 equals 5 times 6. So 6 times 5 equals 30. And they're breaking down the 6 by doing 5 times 6 is the same thing as 2 times 3. Or 5 times 2, multiply it this way. 5 times 2 is 10, and then times 3 equals 30. So 36 is 4 times 9, or 9 times 4. So they're breaking down the the 9. They're going to break down this 9 to 9 times, there's 3 times 3. Or 4 times 3 is equals 12 times 3. And if you don't know that from the top of your head, 12 times 3. 3 times 2 is 6. 3 times 1 is 3. 36. And that's it. And that's what we have. Then this is from our classwork for today. Our classwork for today is something, oops, this is interesting. So they want us to figure out what can you tell about this growing pattern? This is a fun one. What can we tell about this growing pattern? So for picture 1, we have 3 dots. What's going on with picture 2? We have 1, 2, 3, 4, 5 dots. And then for picture 3, we have 1, 2, 3, 4, 5, 6, 7 dots. And what do you think the fifth picture will be? But first we need to figure out what's going on with this. So you have, in the first picture, you have a double. It looks like they're just adding the 2, right? They're adding 2 to each picture because it starts with these 3. It starts with these 3, and then they're adding 2, and then these, and then they're adding. But what they're doing, what Peter, I don't know if his name is Peter. What do you think the 4th and 5th pictures will look like? Peter makes this table to represent the pattern. So in picture 1, there's 3 dots. In picture 2, there's 5 dots. In picture 3, there's 7 dots, but there's a pattern. What do you think picture 4 is going to be? Well, we got to figure the pattern out. So in the first one, picture 1 is 1, I think. 1 plus 1 equals 2 plus 1 more equals 3. For picture 2, it's double. So what it is, it's double plus 1. Double this, double picture 2 plus 1 more. So if it's double 2, it should be 4 plus 1. 1, 2, 3, 4 plus 1. So it's double 2. Plus 1 equals 5. For the third picture, it's double 3 plus 3 equals 6 plus 1 more should equal 7. Yep, 1, 2, 3, 4, 5, 6, 7. Okay, so for the fourth one, it would be plus 4, which is 8, plus 1 is 9. Okay, for 7 of them, it would be plus 7, which is 14, plus 1 is 15. So the answer is 15. So for 10, it would be 10 plus 10, which would be 20, plus 1 would be 21. For 15 of them, it would be 15 plus 15, which would be 30, plus 1 is 31. What relationship can you see between the picture number and the number of circles? The number of circles is 1 more than double the picture number. So that's what we were doing. The picture number, which is the picture number is 1, this picture number is 2, this picture number is 3, plus 1 more. So picture number is 2 plus 1 more. So 2 plus 2 plus 2 plus 1 more. 2 plus 2 is 4 plus 1 more. 4 plus 4 plus 1 is 1 more. So it's the number of circles is 1 more than double the picture. Do you think the 15th picture will have an odd or even number? Well, let's see. Let's go back to what do you notice about all of these numbers? 3, 5, 7, 9, 15, 21, 31. What do you notice about those numbers? How can you tell? Well, I know that if you double a number, it's usually even, but if you add 1 more, makes it what? Odd. So that's what I would write. All of these numbers, when you're doubled, is an even number, but then you have to add 1, it makes it odd. Okay, and that's it for today. Thanks for coming.